Hello?
Hello?
Yeah, can you hear me now?
Are you? Yep, right now there are
Hello?
no interruptions, drops.
Yes, yes, cool. Yeah, there was some issue with the internet call today. Okay.
Just give me a second, just
Um,
connect my earrings, sorry.
mhm.
1, 2, 3, can you hear me?
Yes. Uh-huh.
Oh, great.
Cool. So yeah, can you briefly tell me about yourself so that I can adjust my interview? Yeah.
Oh, tell me about myself, just like in an interview, just, it's still something weird about the connection, but did I get it correctly?
No,
I
I
mean,
mean like
just present.
sorry, what?
Oh, I don't know, it's
Hello?
still, hello, yep.
Yeah. Uh-huh. Yeah, I was asking like how many years of experience so that that will help me to adjust my interview. Yeah.
I'm really sorry, I didn't get you, it's just the cut of the internet connection. Could you just repeat it once again, sorry.
Oh, yeah, I was
Sure.
asking like how many years of experience do you have?
How many years?
So that I
Okay,
can
okay.
check.
Okay, yeah,
Mm-hmm.
I see. I have 4 years of experience.
Okay, cool. Um, yeah. So we can start off with a somewhat medium problem, and then if there is time, we can jump into a hard problem. Does that sound good?
Okay, sounds good, yep.
Okay. Okay, cool. Um, you can select your language. I just picked Java to check, but you can pick a language of your choice.
Do you mind I just pick up the C sharp because more what you mean is
Okay, cool. Mm-hmm.
it's just quite is it duplicated? I don't know. Let me just clean this up and just pick up C sharp from scratch. Sharp. Okay, let's go.
Cool. Um, okay. So let's say we are given. Um, have you heard of a problem called rod cutting problem?
Road cutting problem. I
Yeah.
might be, but not from top of my head.
Okay. So let's say I will detail out the problem here, and if you have heard it and you know it for sure, then we can skip it and we can go to a different problem.
Mhm.
Just let me know.
Okay.
So if we are given a rod of length, let's say 5, and we are given so these are the lengths. These are the different possible cuts we can use on that rod, right? So we can have either a cut of length 1, 2, 3, 4, or 4. Yeah, and then price prices of each cut, right? So that would be like that is, let's say, $1, $2, let's say $3, $2, um, $2, right? So these are the let's say maybe like $4 or 5. Yeah. So these are the different cuts of the rod, and these are the different prices. And we want to find like what is the best way to cut the rod so that we can sell it for the maximum price.
Okay.
Uh, like basically like what kind of cut configuration can we cut this rod into so that we can sell it in the
Okay.
maximum price. So let's say one example is 1 plus 1 plus 1 and so on 1. It will give us 1 multiplied by $1. 1 multiplied by $5, which is $5 total, right? So if we cut the rod only in a cut of 1, we can cut it one
Mhm.
time with just cut of length 1, and the total price will be $5. Similarly, if we decided to do like 2 plus 2 plus 1,
Plus one.
the what? Yeah, so
The price will
what
be
would the
7.
total be in that case? 7. Okay. So similarly, there are all different possible configurations. The maximum price
I
you
see.
can get out of this product.
Yep.
Mm-hmm.
Yeah. I haven't heard about such problem, but it sounds quite similar to the coin change task, and we can jump on to this. For example, it's definitely the problem for the dynamic programming. We can just start from bottom to top, find out the best, keep the maximum price for the current or length, and the combination of cuts. So, do you think we can have a try for this task, or is it the right direction for that problem?
Yeah, sounds like a good direction. Yep.
Okay.
Do you think it'll be
or
bottom to top or top? Yeah, it'll be bottom to top. Okay, cool.
Bottom to top. Yeah, we start from the 1. It will be yep. Put the price. Okay. And yeah, we're going to increase the length of the rope and increase the number of the cuts. We start from the 1, then we have a 2-dimensional array of the dynamic programming, and we'll increase the number of coins, and by one and another direction we'll increase the length of the rope, and we will get the maximum on the when we have all cuts and the full length of the rope. But I don't know, each step we just compare the previous maximum. We just make a maximum based on the same length of rope, but the less number of cuts, and just check if they have a cut minus the length of the current cut on the current row of the cuts.
Okay.
So it's just basic dynamic programming problem, but yeah, we can code it. Why not?
Can you write out the recurrence relation, how you would find the maximum price for a new row, new cell, basically?
Yeah. So we will have the DP. Let's say I'll put it in the comments. Yes, I will not just write it, see the code, or okay, because for me it's quite straightforward. So we have the length of the rope. Yes, length. I don't know, rope. Road. And we have the cuts. And we have a DP, the length. Here we have the length, length, and here we have
Are you writing something because I can't see it on the
it was for me as well. I just noticed the latency is quite big. Where from? Maybe it's not so anonymous. I don't know. Because when you just type something as well, I noticed that only after a couple of seconds.
Oh, okay.
Okay. Public int not cutting. Can you see something, or it's still nothing?
I can't still see anything. Let me refresh my screen. Yeah, 1 second. Are you outside US? Maybe sometimes that happens, I guess.
Yeah, I'm outside. That's a basically the problem. I'm outside of this. I'm in Europe. It should be quite late for you right now if you're in US. Or early.
Oh, it's quite. It's 7 o'clock in the morning. Yeah, that's
7 o'clock.
Hello? Hello?
Hello,
Hello?
can you hear
Can
me?
you hear me? Hello?
Hello. Can you hear me?
Yeah,
I
I
can
can
hear you.
hear you.
Oh, great. I just connected through my laptop because I rather the count on my mobile phone. It was not so. I know we were about 10 minutes with the US. It's quite expensive. Uh, can you hear me? It's fine. What about the editor?
One second.
Can you see me?
Yeah, I just switched to my headphone. Yeah, now I can
Oh,
read the problem as well. Yeah, the screen is
oh,
refreshing as well. Okay.
oh, great. That's so. I'm just trying to start not implementing this. So we have the road length is just as an input, and they have we need the prices as well.
Mm-hmm.
Uh, prices. So that's our
Yeah.
input.
But
Let's.
do you really need the cuts array or the length array? Because prices
Mm,
array will always tell you the total length, right? Because prices will always be for 1 to n minus
oh, I
1.
see. I see. Yeah. Yeah. Oh, the prices always will be for 1, 2, 3, or for n minus 1. Just the maximum of the cuts is just n minus 1. Yes, of the rope.
Yeah. Uh-huh. Yeah. And
I
even
see.
the cuts, you don't need cuts as well, right? Because cuts, cuts
I
will also be
see.
1
Just
to n minus 1.
also be 1 to n. Okay. In theory, it might be not so linear. I mean, the incremental by 1. The cuts might be in real world.
Oh,
But yeah,
okay.
this is such assumptions, of course. If we have such just arithmetic progression series, just 1, 2, 3, 4, 5, and the prices accordingly. Yeah, of course.
Mm-hmm.
So it means our road will be prices length plus
Mm-hmm.
1.
Okay.
Uh, Yep. And we have the wire length, just call it prices. Oh, okay. Maybe it would be better to do like that. Rod length plus 1. Let's initialize our DB, dynamic programming, just to memorize our previous results here. So we can put the length of here, and the number of coins will be in the second dimension. Less than. So TPI. So we need to write here.
Yeah, I think there was some issue. Yeah, but now I can hear you fine.
Yeah, I mean, yeah, just as soon as. So, so we have the integer here and
Okay.
initialize by length of the prices here. Could we just initialize this one as well? First, let's just step by step. So we we need maybe it's might be done in one iteration, but I'd like to do this baseline separately. It means we can go through the length. So I believe it would be better to have here the length, you just increment it by this one, and here by rod. It would be more straightforward and more logical and less than rod. And here we have just start from 0. It means we have only first price, I mean by 1. And here it will be dy d0, and here by rod we will get the.
So by rod, what do you mean? By rod, you mean the cuts or?
Just the length of. Just here is our initial rod of length of rod.
Initial length of rod. No, so I mean like this variable on line 18, the variable rod as well as and length is the total length. Okay.
Length is just the length of the prices. Yep, by 4.
Oh, okay, I see. So you have length of the prices, and then you increment it by 1, which is length of the rod.
Yeah, let me just rename it. It's just there are two main problems: naming and the validation cache, and it's length of price. So I'll have the length of prices here. I'll have the length of rod. I need to iterate through the length of prices and initialize here the length of rod. So and as a baseline, I have only one. I mean that I'm cutting by 1, and it means I need to price is 0 multiply by length of rod. It will be my baseline. I'm just cut by 1, and just the sum of the ones. It means just 1 multiplied by length of the rod. It will be my. So I need the here. So by my length of rod will be the I, because I'm just incrementing y by 1. I'm going to for the length of rod here.
Okay.
And I have a dp0i equal I multiply by prices 0. This will be my baseline. And then I have a two for loops where I equals 0, I less. We can start from 1 because we already fill the 0 level, then less than. So here we need to, need to go from length prices, I++. So about the time complexity, the time complexity will be, if we have this m, it's called the length of m, number of prices m minus 1, it means we will have a quadratic time complexity. Because we're tracing this have 2 for each loops. So yeah, and about the space complexity is also a quadratic space complexity because we are storing the previous results in our DP array.
Okay.
Is it possible to do this better? Let's just implement our first, and I think it's quite a right implementation, and then we'll maybe just figure out how we can improve how.
Let's do an implementation, and then if we can see if we can optimize it even further. Yeah.
So I need the second array. So here yes, the most important part, IG, it's math of maximum of TP I minus 1 for the same road, length of road, and we also need to compare the TP I. So we have the I, we have 1, 2, 3, 4, and it's just the length. It means we need to sorry, it's the prices. Yeah, G is the length of rope. Yep, it's I in the same level, but G minus I. Just G minus I plus prices I. We are just adding the one cuts, just comparing the our previous results, the previous number of cuts, for example, when they just making just maximum number, and we are just back into the length of the cuts of the current level of cuts. For example, we are and we just so we here prices I, yeah, we add one more cut to this current length, and we need to sum up it to the maximum of this when we have this previous the rope less by the I. Let me just check it really quick. If we have this because we're zero base, so because we have I1, but we need to go back by 2, I believe. So for example, if we have on the road length 5 here, and I will be, for example, 1, it means our row cuts its a length of 2. We need to, so is it really matter just for G? I think G equals 0, it doesn't matter. I just messed it up a little bit because we treat our G just length of a road will be 0. It's not make sense. It's just always 0, and we need to just start from 1. And it means from here we need to add plus 1 and start here from 1. It's not so hard, but because 0 equals and let's just here just not mess with the indexes. So G equals, so we have the G equals 5. It means the length of 5. We have the 1. It means we need to cut it 2. We should go to the 3, length of 3. But here, just G5 minus 1 will be only 4. It means we need to minus 1 because it's here we just 0 base. And now we have the G minus 1. It means we need to result for the road length of 3, and that's a proper minus 1 here. So I think we've done our bottom-up algorithm, and we can return dp. How many? We have a length of prices minus 1 and length of road. Length of road. Like that. Yeah, we just add plus 1 here. It means we can use the length of road -1, and it will be our maximum value for the. So let's just check it more carefully, our approach.
Okay.
So let's say we have the prices like from your example, yes, 1, 2, 1, 3. May I just use the 3? Okay, let's 2 and 5. Okay, 1, 2, 3, and 5. So length of prices will be 4. Length of road will be 5.
Okay.
So the DP then will be here. It will be array of arrays. So here just the length of this arrays will be 4. It means we need to have 4 arrays here, and inside each array we'll get the length rolled plus 1. It means the 6 element inside each. So and with TPI, yeah, it was just 6. 4, 5, 6, because initialized by default value was zeros. So so it's our data. It's our and here we start our initialization. We put the first row here. We place I by index and multiply by the price. And here just the price 1. It means 0, 1, 2, 3, 4, 5. And it makes sense. It's just the same as we got here. If we have only one cut, I mean, we can only cut by 1. We can get by maximum the $5. So then we have our.
But can you see the bug on line number 28?
28. The length of road plus equal here we need to place, because we have a length of road plus 1 here and we didn't reach 5 here.
Okay.
Yes. Good. Yes. When this 2 for loops, we start from the first row. Yes, it makes sense. And we need to get by the length of road here is the same issue as in the line 28. So we go to the DPI here, just a 0. Okay, I need to compare because it might be index out of range. If G minus 1 0, and we have this else we have this value, because we might have the length of the road less than our cuts on the beginning of the iteration, and if we still just did not get the index out of range here, I minus 1, it's fine because we start from the 1. Yep, and we need just to make sure this one is just so the prices. We have the length. We might get the length is the length of prices. It's fine. Here, this index is also in the range. Semicolon here. So let's we G0 1 and G0. It means we are here. G minus 1 it's less. It means we need to go here, and it will be 0. When we have the G1, G minus 1 minus I, it's also less than 0. It's still here. It means it's 1. G equal 2. 2 minus minus 1 minus 1, it's 0. It means we need to have them choose the maximum between the 2 and between the 0 plus price 3. 3 it's bigger than 2. It means here we have a 3. So then we have 3 G. So the 3, which obviously we are in this branch of this statement, it means we need to pick up the maximum between the 3 and the 1 plus 3. It means it's 4 bigger than 3. We can pick up here 4. So just make it sure. We have the 3 minus 1. It's 2 minus 1, it's 1. Yeah, 1 plus 3, it's 4. And let me just finish up here. 3 plus 3, it will be 6 here. And here we have the 4 plus 3, it will be 7 here. Does it make sense? By cut of 4, by 2, yeah, we have a 7. It's fine. It's our.
How did you get 7? So you look at 5, right? Maximum of 5, and then
4 plus 3.
4 plus the current price. No,
current price.
Yeah, the current price is 3.
3.
Okay, cool.
I'll get the 7 then. So we can finish it up, of course, because here just 0, 1, 3, because it's the length of the cut is. So yeah, we have a road length of 2 only, but the cut. No, the cut is we have a 2, but the maximum will be 3 because here. The cut is 3. Length of cut is 3. It means here just might be. It will be interesting. We have a maximum. We have 4 here, but we need to go to the 0. 0 plus 2. 4 is bigger than 2. It means still 4. We are here the 6. We're comparing 6 and 1 plus 2. It means it's still 6. So here we.
So one quick question, like how would you get 7, right? Because I'm looking at the problem, which so just like eyeballing it, right? The maximum I could make looks like it is 5, right? Because I can I can sell like 2 plus 2 plus 1, which is 7. Okay, got it. So I can get maximum of 7 by selling 2 plus 2 plus 1.
Yeah.
Okay.
Hey, it's just you wrote it here in the beginning of the task. Here,
Yeah.
it's just on the line 51 and 52.
Yeah. I was just a little confused, I guess.
No worries. So let me just finish it up really quick. We have a compare between the 7 and the maximum is 3 plus 2. It means 5 and it's still 7. So let's just do it quick here because the length of 3 and 5, it means we need 5 and 6 is still 6, and 1 plus 5, it's still 6, and the maximum will be 7. And the result, we need the length of the price. Length of the price is just 4. And the index will be 3. And the length of road, it's 5. And the result will be 7.
Okay, awesome. Can you quickly like run it?
Oh, yeah, sure. Of course, we can do that. All right. Line. Okay. So chapter is oh, here.
Nice. So if we like, I will just quickly ask like, because we don't have, do we have enough time for another question? I think we might have. Okay. So let's say like if we want to optimize this, right? Like,
Yeah.
in which dimension can you optimize it? Like in terms of time complexity or space complexity?
I believe in space complexity, maybe it's we do not really need the second dimension.
Mm-hmm.
Maybe it would be just enough use one dimensional array
Okay.
and just compare the previous one and accumulate the numbers because um, yeah, I think we just fill it by and just iterate the same array because we are just comparing the previous numbers and yeah, it might work. For example, if we'll because we are doing pretty much the same, we just can fill this array and just iterate and just compare the current value and the price minus the previous one and just update the value here immediately
Nice.
because yeah, and we just reduce the space complexity by yeah by one dimension. It will be big O from an O in.
Cool.
I think that will work. About the time complexity,
Mm-hmm.
maybe there is some hacks. I'm not sure right now. I need to figure out about it a little more. Maybe we can somehow estimate our maximum, and if we reach that, just stop our DP, and
Mm-hmm.
somehow that's one of the options. Maybe we can do some math and figure out what the maximum total maximum, just our rough estimation, but I'm not sure right now how to do that from the top of my head. Another way to optimize the DP, so there may be the maximum here. What else? What should be done? Maybe done. So yeah, we have the two iterations, maybe. Mm, I'm not sure right now. Maybe we can jump. Yeah, here jump from the I, for example, because we know we will get here if statement just the same value. We just can start from the I from here. Because we are doing pretty much a lot of stuff, for example, for a large number of length around. Yeah, that would be better in terms of time complexity. We just the overall, I mean the worst time complexity it will be this. I don't know, it would be better of course, but I mean in terms of the BQ notation it will be the same, but in real operation of course it will be less.
And if you were to write this like recursively, how would you do that? Like some pseudocode?
Yeah, recursively. Yeah, I think we have if we have our root cut problem from something, let's call it length
Actually,
of f. Yep.
yeah, actually, let's write the code if you want to, because we have 15 minutes, so I'm not sure if I can. Or do you want to? If you are confident about recursive, we can do a different problem if you want.
I think I'd like to hear this hard problem. Just that's for this problem I knew the solution, at least some solution. So, but I have a struggle with the hard problems, at least on lead code, and it would be great to just at least hear it from you.
Sure. So we have, this is called like egg dropping problem. Have you heard of this?
Egg dropping. I'm not sure by naming, but could you just explain me?
Sure. So we are given like n eggs, right? And we have like x number of floors, and we want to find like let me add this so that you don't get errors. This, I mean, maybe if you have time. So if we have n eggs, x floors, we want to find like the minimum number of attempts that is required to break an egg, to detect which floor the egg would break from in the worst case, right? So like 9 attempts to figure out which floor egg break from worst case, right? So let's say if I have 5 floors, 1 egg. In the worst case, what would you do, right? You would just try it out from each floor. So in that, you would expend 5 attempts, right? Are you following?
Yeah.
And if you have 5 floors and 2 eggs, you can do this problem a little more aggressively by starting out. Let's say like maybe like at floor number 4 or floor number 3 or 2, and then drop the egg from there. And if the egg breaks, you know that the problem reduces to
First.
1 egg and the remaining floors, right? Remaining bottom floors. If it breaks from, let's say, floor number 3, right? So you're left with 1 egg and remaining 2 floors, because 3 minus 1, right? You tried from 3, and if the egg doesn't break, right, you're left with 2 eggs and 3 plus 1, like again 2 floors, because floor 4 and floor 5, right? So you're left with these 2 floors, and here you're left with 1, 2 floors. So do you follow?
What does it mean the break the floor? Sorry, I didn't get this.
What do you mean the egg?
What we're doing? Sorry, we have a 5 floor, 1 egg. We're just dropping the egg on the floor, or
yeah, we are just so we go to floor 1. So we have 5 floors, right? So floor 1, floor 2, floor 3, floor 4, floor 5, and then we start with we are just given one egg, so we can't go to fifth floor and try the egg, right? Because if it breaks, we don't have any more
Oh,
eggs
I
to
see. I
experiment.
see. Yeah, yeah, yeah. I
Yeah,
see.
so we basically do a brute force search starting from bottom, right, bottom up.
Oh, I see.
And but in the second scenario, we can be a little more aggressive and try out, like we can start from, let's say, floor two, and we drop the egg, and if it breaks, then we know that the answer, like, we
Within
don't need
one.
to go, yeah, we don't need to go to upper floors. We just need to try out from bottom floors. And if it doesn't break, we know that trying out bottom floors doesn't help anymore, and we go to the upper floors, right? So floor
Okay,
four
I
and
see.
five, and mhm.
I see. Yeah. Good. Uh, okay. I see.
And we
So
basically need to find out like the minimum number of attempts, right? So if we tried it from floor one, what is the attempts we tried it from floor two? What is the number of attempts, and then minimum of all those, right?
okay. We need the minimum for the worst case. So yeah, the maximum, just the opposite side, is just the number of eggs. Or no, we have only one egg and 5 attempts. Sorry, we have only one egg and oh, I mean the one attempt per. I mean on each attempt we have only one egg. Yes, and if we drop from the first floor and but
Mm-hmm.
why
I mean, it
did
is
we get 5 attempts for the 5 floors and one egg?
yeah.
And five.
So you have one egg, right? So you'll try it from first floor. If it breaks, you get the answer, right? First floor is the floor where the egg breaks from, like the lowest floor from which the egg breaks from. But if it doesn't break, you want to try second floor. If it doesn't break, you want to try third floor, and so on, right? Because that is the worst case, right? If it doesn't break.
Okay, yeah, yeah, I see. Oh yeah, on each attempt we have the one egg or 2 eggs, and we are just dropping it where we can. And how many attempts is just in the worst case we need?
Mm-hmm.
I see. I see. I see. Let me just to think about it a little bit more. So, uh, if we could we do the dynamic programming here as well, because it's just obviously we have this floors and eggs as well.
Mm-hmm.
And for example, if we so for the second option we have 5 floors and 2 eggs. It means how many times we need in the worst case. We have for one egg. We have two, and if it's not, it means just by one attempt we can do this. Because just give it a second. Oh no, we still need to figure out is
Yeah, so we have to do the testing, right, from each floor anyways. It's just that the problem becomes an overlapping problem, right? Because if the egg breaks, you reduce the number of floors. If the egg doesn't break, you still reduce the number of floors, but with the same amount of eggs. And if egg breaks, your eggs reduce and the floor reduce. An egg don't break, you have the same eggs, but reduce floors. Yeah.
yeah. So yeah, it sounds like the dynamic programming problem as well. As you
Mm-hmm.
mentioned, yeah, we have on each attempt we need to go through them. So yeah, here in this one, just to if we have 5 floors and 2 eggs, as you mentioned, we starting from the 2. We always start from the number of eggs from the second floor.
Mm-hmm.
Is it our approach to make it? Yeah, we just because we
But
have
that depends, right? Like if because there are like overlapping subproblems here.
yep,
So if even if you start with one with the first floor with two eggs, and depending on the answer, the other, like the subproblem answers would also change, right? So you cannot like do a binary search sort of here, right? Starting
yeah,
from like half the number of floors, because we want to try out all the floors. Like we don't know where it will break from. So that, yeah. So maybe if you do binary search, it might optimize on the number of cycles you spend to find the minimum number of attempts, but the minimum number of attempts would still be the same.
Yeah. Binary search is, yeah, we can just divide and conquer our problem. And here, when we drop from the middle, it means from the third floor, we just reduce our problem. No, it's just overlapping problem. Yeah, as I said. Okay, that's really, I haven't heard about this problem. I need to figure, let's think about it more. So yeah, we can binary search, just pick up the proper floor. So should we do it iteratively? Oh no, we need the number of attempts. So it's just, let me finish the second example. How many? It means we need 2 attempts. Oh no, I believe 3 attempts in the worst case, isn't it? The answer should be.
5 floors, 2 eggs. Yeah, we'll have to do that. I don't know from top of my head, but you'll have to try out all the possibilities.
So you for after the first attempt, or no, even maybe 2 attempts. After the first attempt, you find, for example, you drop the first egg. It means you narrow to, or found, or you narrow to 1 or 2, and you have the 1 egg remaining, and you drop into this. And for example, in the worst case, you drop from the second floor, or it's from the first floor. It doesn't matter, because we still need to find out and eliminate the 1 from here. For example, maybe it might be, I don't know, if it's not broken from the second floor.
Then you need to try on the first floor as well.
Yeah, but in the worst case, we need the 2 attempts, because in the worst case, we still need to.
No, but you're doing 3 attempts, right? So from floor 3, you tried dropping the first egg, and if it broke, you went to below floors with 1 egg, and then you have to try all the below floors with that 1 egg.
So just once again, attempt, it's just on each attempt here we have the 2 eggs, or attempt is just to drop the ball as soon as we drop the ball.
Yeah, so attempt is irrelevant of the output. As soon as you drop it, that is an attempt, right?
But what does it mean that the number of eggs is not relevant then? If we have...
So that is relevant, right? So if the egg breaks, you lose an egg.
Yeah, but it's still attempt. No, if it's not broken,
you get to use the egg in further attempts, right?
It's not counting for the attempt if it's not broken. Okay, I see. Each broken egg is just equals to attempt. I see. So in the worst case, then it's just a 3, because we try to on the third floor it breaks. We try to on the second floor, for example, it breaks, and we try to on the first floor it breaks.
Oh, so you can't. So if you are in the middle floor, right? Let's say third floor, and you drop an egg, it breaks. Right, you cannot try the second floor directly, because if you try the second floor and you lose another egg, you don't have any more eggs. So you'll have to try from first floor again, see if it breaks. If it doesn't, then you try the second, and if it breaks from the first, you have answer that it breaks. That is the lowest floor where it breaks from.
Oh yeah. It means 2 attempts then. On the third floor.
So it will be still 3 attempts, right? Because 3 attempts, because from third floor 3, we try and let's say egg 1 breaks. It, and if it breaks, then we are left with 1 egg and bottom or like first 2 floors. And now to figure out where it breaks from, it reduces to the first problem, right? Like where we have 2 floors and 1 egg. So
Yep.
the maximum number of attempts will be 2 here for that problem. And then 2 plus 1 is 3, right? Because we spent 1 attempt here on line number 54 for the first problem. And then we spent like 2 eggs here. So 2 plus 3, 1 is equal to 3 attempts.
Yes.
So basically, like if you, this is also like similar to like bottom up building, where you try to find out like one egg, X number of floors, 2 eggs, X number of floors, 3 eggs, X number of floors, and so on, right? And then you, with 1 egg, you start with 1 floor, with 1 egg, you start with 2 floor, and with 1 egg, you start with 3 floors, and you sort of like build it bottom up, left to right, and
Okay.
then, yeah. But here it's like the aggregation of this, but like to find out the value at a particular cell, it's a little more complex. Yeah.
Because we need to keep in mind this binary and binary search approach.
I mean, like the binary search actually is not needed. Binary search is only like an aggressive strategy to find out the answer sooner, and that may not help either because like of the way like this problem is structured. Yeah.
So if we have this, for example, in terms of our DP,
Mm-hmm.
we have the 5 floors. For example, we have 1 egg, and we increment in the floors. Yes, it just be 1, 4. It's just here. It just will be the same. The 5 here.
Mm-hmm.
Because it's just the number of attempts which we should determine in the worst case. So then we have the second floor. We add the second egg.
Yeah.
It means for the 1 floor it will be still the 1. For the
Mm-hmm.
2 floors, it means still also 2. Yes, because it might be we might start from the second one.
Mm-hmm.
It breaks. We need to try the first one. It breaks.
Yeah, if the floors and the eggs are the same, then yeah, it'll at least take like it'll take at least the number of attempts as the floor, right? Yeah.
And the third one, if we have 3 floors,
And 3 floors and 2 eggs, yeah.
and 2 eggs, what's going on there? We have the 3 floors. It means we can start from the second one. It means we need still 2 attempts. Yeah.
Yeah. So you have 3 floors and you have 2 eggs. Yeah.
And it means it's still 2. Okay.
So basically, like if you.
Yeah. I see. Because we have the 2, we can, from the number what we are doing on each egg, we are dividing our number of floors by 2, isn't it? It means.
Mm-hmm.
I mean, we need to compare. We need to go here to get the 2 from here, because in that case we have 2 floors. From to here, because we're using 1 egg, and we drop our problem to 1 egg, 1 floor. So it means.
So you're saying if you drop your egg from which floor? So you also have to take into account, like you can drop your egg from first floor, from second, from third, and depending on that, your sub-problems will change. And based on those answers, you'll find the minimum number of attempts, right? So of all the possible floors you can throw from, like 1, 2, or 3, and if you throw it from one, you'll get a certain answer one. If you throw it from second, you'll get a certain answer two. And if you throw it from third, you get a certain answer, right? So of all these answers, which is the minimum one? So you pick a min of all of these, right?
I see.
Yeah. Yeah, this one is a harder problem. I don't think like it's yeah. This is usually not asked. So it was only asked to me in like one interview. So
Okay.
yeah, I have not heard this quite often. Um,
But it's still the DP problem, right? It's in my strong area of the
yeah,
DP.
DP or like
It might be a
recursion,
complicated recursion.
recursion memorization. Yeah, same thing.
I see. I think we're around the time. Thank you very much. I
Yeah,
just
no problem. Do you want any feedback? Like you did pretty well, so I
yeah,
was
it would be
not.
great. Yeah.
Yeah. Okay. So do you want me to give the feedback right now, or do you want me to leave the feedback there?
If you have a time, it would be great to have it right now. I don't know. I don't
Okay.
mind.
Sure. Yeah. So for me, like I think like you did very well, like with the problem, and then you also explained the time complexity and space complexity without me having to ask for it, right? So that is a good thing. And then you also walked me through an example as soon as you finished the problem or as you were typing the problem, you figured out all the bugs on your own. One slight suggestion would be to like eyeball your solution before running it, right? To figure out like if there are any obvious compilation errors, right? You don't want to try like X number of times before you get it working. So I would say
Mhm.
just like eyeball it, make sure there are no obvious mistakes, and then run it so that you minimize the number of attempts it takes to run the problem. Sometimes some interviewers are like sort of like watching you, like how many attempts you take and so on.
I
Uh,
see.
so yeah, so you might want to do that. Other than that, everything was pretty well, very good. Yeah, you explained the space complexity, complexity, and I don't know, like, did you discuss multiple approaches? I don't think so, right? You just straight went into
Yeah,
DP.
just straight down to the P. Yeah.
Yeah. So if you can like think of multiple approaches, you might as well throw that in and discuss their trade-offs, right?
Okay.
Before or after you like, I think like if you discuss the trade-off initially and ask the interviewer like which approach do you want me to go with, that will be also a good thing to do. Yeah.
Okay.
Yeah.
Great.
Other than that, everything is very good. And for system design, how are you preparing that?
Oh, I'm doing the course of the cracking of the system design interview on the what's called on the educative, and I'm
Yeah.
also watching
Okay.
some videos on the YouTube.
Cool.
So yeah, I have this link to the, and I'm registered in this whiteboard platform and try
Uh-huh.
to draw something similar from the educative IO courses about the system
Uh-huh.
design. But yeah, I'm just quite. It's for the first time. I see it's quite complicated. Might be. I don't know. There are a lot of the topics to cover and just not for. But yeah, I I hope I'll finish all of these explained examples from the course. Maybe it
Mm-hmm.
would be helpful for me to just to memorize all this approach. Of course, I have an experience about the design the systems, but not for such huge like the Facebook or Twitter, and it's much more.
Yeah.
But
I think like the I think like the more important thing would be to understand all the building blocks, right? Like consistent hashing, load balancers, cap theorem, like all of these things, just to keep them in mind, and like you can apply them to all sorts of various solutions like WebSockets. So they discuss all of those. So just remember, like you have all these tools and you can use them. And this is another great book which I put on line number 6. So that book basically is about like distributed systems.
Okay.
So I would say like if you are done with all of like preparation for system design and you think you want more, then this might be helpful as well.
Yeah, I also applied to the course about some microservices architecture,
Mhm.
and I have an experience. I'm from the .NET world and experience in the Azure more, but I've also tried to fresh up because there are a lot of similarities between the Azure and the AWS. I think it's just to mention them in the system design jury as well, all these components, because it will really help to build and use the service or the software as a service. It's much easier and just to reference them during the interview. I think is it helpful? I mean, is it a good approach to, for example, mention S3 or something like some Elastic's load balancing just in particular during the interview?
Yeah, I think like it is helpful like to like know maybe like you don't have to know like a particular technology as long as you know like the underlying principles, right? So you can come up with a generic answer like a load balancer. You don't have to like pick one specific one. But if you have experience with that, that is obviously helpful. But you don't need to, right? So you can at least yeah learn from like any system and then apply the underlying principles to any generic system design interview.
You know, I have one concern about this. In this educative I/O, they are usually on the beginning of this brainstorm or the system design. They try to estimate some metrics about some or throughput or the latency or the DB size, for
Yeah.
example. We
Hmm.
try to estimate how many users, and then we multiply the size of the image, and they just figure out is it really important, for example, to say we need to 50 terabytes of database per year. I know it's a
Um,
number. It's really great to have
mhm.
something written down about the design and system, but it's hard to. Maybe I just okay. I can multiply by thousands and maybe bytes, but it will be not so.
So you mean like
So fun.
it is hard to reason about the design, like the design you're using, will that satisfy the constraint which you came up with, right?
Yeah, and
I
I
think
can
like that is
come up.
mainly. Uh-huh. Go ahead.
I mean, I can come up with some numbers, but I'm not sure I might relate them to the because
Actual
yeah, because
design,
I
yeah.
know the difference in the 50 terabytes and maybe 5 gigabytes, but in terms of the system design, I'm not sure how. Yeah, I can see that I need to just distribute them, this data, and horizontally scale. Uh,
Hmm.
oh, maybe based on that numbers, we need to decide do we really need the scaling or not, maybe something like that.
Yeah, based on those numbers, basically, like from what I know, like you would figure out like what kind of server, how many servers do you need concurrency, do you need you can you do it in serial mode, do you need to do parallelism with threads, all of that, right? Like how many storage devices do you need, all of that. So you can just like I would say like just do that for the sake of doing it. And if the interviewer asks how are you going to actually implement it in your design, you can talk about like how many servers you'll need and how much RAM will you need and all of that.
Yeah.
Mm. Cool.
Yeah, it's complicated because I'm not sure how many rounds do I need to support, 30, I don't know, thousands requests per second. I don't know, or CPU. How many CPU do I really need? Uh,
Oh yeah, like one of the things which is also really helpful is like to have like some baseline numbers for like how much is the usual network delay and how much what is the usual time it takes for interprocess communication and all of that, right? Like some baseline numbers. Those are also useful sometimes. So there is like you can find those charts on the internet where they give you like these
yeah,
numbers, standard
good point.
numbers. Yeah. Cool.
Yeah, thank you.
Yeah,
Thank you
thank
very
you.
much.
Yeah. Have a good day. All the best.
You too, you too. Have a good
Yeah.
night. Yeah, it's too late for you. It's evening. Good evening. Yeah, thank you.
Yeah.
Very,
Bye.
very helpful. Thank you very much.
Thank you. Yeah. Bye.
Bye, bye.